Well, why don't we get started?
Okay.
Alrighty. So, this is, I looked at our webinar archive at 2 Green Energy. This is actually our 22nd webinar that we've been doing on a monthly basis for coming up on 2 years, I guess it is. And it's actually the first one on wind. Wind has been mentioned and has played something of a prominent role in a couple of them, but this is the first one that's really about this. And it's about a very special facet of it, and that is microwind. So as Dan, you and I were talking before we started here, microwind tends to be the red-headed stepchild in the whole industry, and people are focused on the 2 and 3 megawatt things that General Electric make and so forth. But what excites me about this is that if this is affordable, and I think the case can be made that it is, it creates an incredible play for distributed generation, and that's going to be our subject today. I'd like to introduce my newfound friend Dan Bates, the CEO of Windstream. Dan, welcome.
Thank you very much, Craig. It's a pleasure to be here.
All right. Well, let's just go through a couple of these things. Mostly this is going to be the Dan Bates show, but I'll tell you what, I was thinking about how to present this, and I always try to keep a kind of 50,000-foot view on what is happening vis-a-vis the energy industry and sustainability more generally. Simply because, as you were talking about, there's now 600 million people without power in India, and that's going to cause an enormous amount of suffering on a hopefully temporary basis. But there's permanent ecologic damage that we're doing on an unparalleled basis here on planet Earth, and it's the issue of sustainability is growing in importance in a lot of people's minds. And the only issue is cost. So a friend of mine famously says, if you don't care what you pay for it, Craig, I can find you all the clean energy you want. But the problem is we do. We do care what we pay for it. So this is going to be a presentation on affordable micro wind. I believe, and this is my slide, not yours, Dan, but I believe that these constituencies at the bottom are probably the most obvious places to go in terms of customer segmentation. And I include greenwashers, by which I mean the people who want to appear green, whose heart really isn't in it. And I think that's kind of a shame, but at the same time, it is a market. And I'd rather have somebody do the right thing for the wrong reason than not do the right thing at all. So, I'm sure you're going to find customers who want this simply because of the appearance it makes, and I presume you're okay with that.
Yeah, we hate the term greenwashing, but I absolutely know that it's a reason people buy our products. It is what it is, but I think I'm with you, Craig, that it's better to do it for those kinds of reasons than not do it at all.
Yes, good. Well, why don't we whip through a few of these slides? I'm
going to go back to your India comment for a moment. There's 600 million people right now who are affected by the blackout. There's 1 billion people in India, and the number that I've seen published are there are 400 million people who live off-grid. So literally the whole country is without power right now.
Wow.
If you think about it.
Yeah, it is remarkable.
Staggering.
Let me, by the way, make a comment on this. Let me just go back to this slide. So there are people who probably are looking for the sound coming through their computer, and it isn't. So if you want to listen to the commentary on this thing, I'm going to just leave this slide up for a minute longer. So just so people can write this down and get into it. Yes, that is a staggering number, and it's a tragedy, and it is one of the issues certainly served by distributed generation in general.
And I can relate, being one of the guys caught on the 60th floor in New York City in the blackout a few years ago on my way to the airport and having to walk down.
Yep.
I get it.
Yeah, I get it too. I did 26 stories in the Williams Tower in Houston not too long ago.
There you go.
Okay. Well, very good. Why don't we just whip through a few of these slides on the company and its management, and then we'll get into the product itself.
Sounds good. Okay, so we started Windstream Technologies here in Southern California in 2008, and it was really the idea of how to harness wind in an urban setting, rooftop wind. Been talked about for many years. The couple of drivers that we noticed early on, and I'll get into the technical details in the subsequent slides, was that obviously you live in the city, a densely packed urban area where you can't put up a tall, massive device because of building code, and then price. So we went at this product and the technology surrounding it starting in 2008 with the idea of coming up with something that would work for the urban setting. And that was really our first driver. It has since segued into other markets. Those markets are rural settings and then off-grid, and I'll get into those. So in 2008, I started this project with some very dear friends of mine, some colleagues. We began engineering the technology up in the University of New Hampshire Wind Labs. They have a very robust wind energy group led by Dr. Klowicki up there. And we did the initial R&D for it up there, and then brought it back to California, where I had some work done with Dr. Richard Wirtz over at UCLA from the Caltech JPL pedigree, whose passion is wind energy and is now our chief science officer. Once I knew the technology would be right for the marketplace, and we had vetted it with smart wind energy guys, I set about trying to fund the company, of course, in the midst of the nuclear winter for the economy, and decided that rather than have a company that was driven by VCs and VC interests, I would see if I could establish a public-private partnership. Knowing there was some labor component in this product, I wanted this product to be American-made. I approached several states to come up with a partnership that made sense to bring that job creation and that clean tech industry to their borders. And I found Indiana was most receptive. I had 8 states bid for the business. Indiana won it, and we ended up in a city called New Albany, Indiana, which is just across the Ohio River, just north of Louisville, in case people don't know where New Albany is. It's a suburb, if you will, of Louisville. That enabled us to establish an academic alliance with the folks at Purdue University and Dr. Sandy Fleeter, who helped us enormously on some of the design ideas. I was able to hire great engineering talent out of the area, primarily from the University of Louisville across the river in Kentucky, where we've hired our lead mechanical engineer, David Dingman, and our lead electromechanical, Stephen Brewer, who did the initial work on our generator design. We then set about the task of building what was truly a unique, small-scale, small-footprint wind energy device, focusing again on the urban space, and designed it through 2010 and into 2011 when we started deploying it and launching our prototypes. First prototypes ended up in Finland, not exactly the best place to be doing a prototype. It's not down the street in case something goes wrong, but we were given the opportunity to be working with the government, the State Department, and Ambassador Bruce Orrick, and I'll get to that in a moment.
Yeah, I think he
was a key driver.
I think we have some photography on this. I have a couple of questions. So
sure.
You mentioned in passing permits. So in other words, this passes. There's some advantage to having a low. I can't remember what the thing. Obviously, the axis itself. The axis itself is under a certain height.
Yeah,
equals you don't need building permits. That would be huge.
Yeah. Let me get to that on the next page. Why don't we bounce
the other
ahead?
Thing I wanted to mention. Here's your challenge, Dan. Is that I know because I fielded comments from these people in the past couple of days. I know they're skeptics, and I'm sure they're impressed that they have PhDs who worked in the design and your chief science officer. But keep in mind the guy who said, "What can you tell me to convince me that this isn't that I shouldn't regard this as just another brand of snake oil that microwind has been, labeled as?" So. I mean, personally, the reason you and I are having this conversation is because you've convinced me, but now you have to convince them. So if you want to do that in the coming slides, that's completely fine. But just make sure we make that happen. This next thing is on management, which I consider important to,
Okay, yeah, and I'll just touch on that. The company was set up by seasoned entrepreneurs. All of us have startup experience in technology ventures, in media in some cases, in a lot of it in energy distribution and sales, and for ESCOs. We have also opened up an international sales group, and military sales, where we have guys who have spent, most recently, 20 years retired, selling now into the military channel where the U.S. military has a mandate, get to net zero by 2030. The Air Force, the Navy, and the Army each announced gigawatt initiatives over the next 4 or 5 years for distributed solutions.
Yes.
And we expect to be a part of that, a significant part.
I can't imagine how you won't be, considering how correct you are that the military has an unbelievable appetite for stuff like this.
That's right. And they're doing it for all the right reasons. Cost savings.
Well, it's cost savings is also saving lives. So, in other words, the most lethal job you can perform is defending energy, which read oil.
Yeah, exactly. Many of the troops that were killed in Afghanistan and Iraq were done so by IEDs on fuel runs.
You're precisely right. Okay.
For those forward operating bases. Good.
And now I want to show this, though I think we've touched on this thing already verbally, so we gloss over this. And just
distributed is important, and I think that's where the world's going. I think energy is going to go the way the cell phone has overtaken that landline, and that if you can create distributed nodes of energy in rural areas, because people aren't going to run transmission lines, very much like the cell phone leapfrogged over that land line, that hard wire, energy is going to do the same thing.
Yeah, and certainly in terms of off-grid application, but I think that for the foreseeable future there will always be a limited amount of that. I'm sure you don't want to limit yourself to off-grid. I know for a fact you don't want to limit yourself to that, especially considering how easily deployable this thing is for people in just the typical, net metering position, or even just having one of these things on the roof, whether there's net metering or not. But I'm sure people are interested to know what the heck this thing looks like. And
right.
There we go. So do you want to just walk us through?
So here we go. So we have 3 vertical axis turbines in a single base with 3 generators underneath it. Now, these devices, each one is a meter in height. And to speak to your question earlier, Craig, about how this thing can get deployed in many cases without a building permit, in the 80s, the FCC said if you put a satellite dish on your roof, which is under a meter in diameter, you don't need a building code, and you don't worry about height regulation, that height limit. I have checked with city engineers and city planners across the country, shown them our product, and said we fall within this FCC regulation. Do we need a building permit to be installed in your city? And in every case, the city engineer has said, no, I don't have a problem with it at this size. That's not to say we conform to laws in every city. It's not to say you can't go into a community where you have a homeowners association that will have a problem with it. It's a case by case. But historically, to date, we have not had an issue with a building permit. We still have to follow all the national electrical codes, all those regulations, of course. But the biggest stumbling block to small wind in the urban setting, published by OWEA, is that 90% of the small wind installations can't go forward due to permitting. Permitting across the country says that from 1.5 to 4 times the height of the mast is your setback from the property line.
Right.
That was a huge driver for our business.
Yes, I can see that. Well, here's the other thing. Here's what I consider to be most important about what we're looking at here, and that is cost per watt. So in other words, and both of them are important. You're going to get to output in a second. And I obviously am not going to divulge anything, specific about that I may know about the cost. But looking at this thing, I think everybody's looking at these blue blades and are saying, what is that? How is that flimsy, unreliable, cheap junk? We're all concerned about cost. What is that? And how if this guy drove the cost out of this thing in a high quality environment, how exactly did he do that?
Okay, so when we set about building our device, one would typically think that looking at a vertical axis turbine like this with a helical twist, and for those of you who are interested in the vertical axis turbine space, this is center shaftless with a gap and overlap, which we found to be the most efficient, and we did a battery of testing and research and development on third-scale models and measured their efficiency to come up with this form factor. But one would think that this would be an injection mold. You'd simply, crank this stuff out of some resin or a structural foam of some type, or even go to the next level and make it some sort of a carbon fiber or graphite type of composite. We looked at all of those. We looked at the cost of building a turbine in those materials, and then we compared it to the most commonly used, most recycled material in the world, which is steel. And we said, if we build this thing out of steel, which is a G90 galvanized 24-gauge steel, we will have a stronger blade than most of these composites at an equivalent weight, right? We can make the steel thing very light. It's much stronger than many of the resins and plastics, possibly not as strong as some of the carbon fibers, but the cost is everything. So we then set about trying to figure out and create a tool that would enable us to stamp the blade segments. And we have spent the last year and a half perfecting that tool. So we are now in a position of stamping out these steel blades at a very inexpensive price. It's an order of magnitude of 6 or 7 times less than a composite.
That's really cool.
That's how we do it. So we also this same SKU, this same device can be sold to our customers in Norway, where we just done an installation, or in Finland, where we survived last year's harsh winter, and in Ghana, where we have customers, or Phoenix, Arizona, in the middle of summer, with no expansion or contraction or creep, as they call it in the plastics world.
No, that's neat. Well, speaking of Phoenix and other places with sun, maybe we can talk about this version of this other SKU.
Yeah, sure. So, as a result of looking at the small wind, micro wind sector, and knowing that we are in an environment here down low to the earth in the boundary layer that typically doesn't experience the laminar flow winds that a utility scale wind farm would find at 300 feet, we decided to put a solar panel on top of it to level out the energy generation across time. So that what we have found with this device, and we have it installed in Indiana on National Guard base. We have it installed in Korea, where we're doing testing, all over the place, actually. We have found that we have a very nice even energy generation capability in the morning when typically there are winds. That wind tends to die down midday when the sun comes up and peaks. The solar panel takes over. Then the afternoons, when the wind picks back up, we start generating energy as the panel falls off in efficiency. The device that we have set out in Indiana that we are monitoring currently is averaging between 1.5 and 2 kilowatts a day.
Kilowatt hours.
Kilowatt hours a day, yeah.
Right. Good. Okay, well, speaking of stats and output and so forth, you want to take us through the highlights here?
Sure. So this is for the turbo mill. This is not the solar mill version. The solar mill just, by definition, adds 230 watts on top of it. But the rated power of the turbo mill at 11 meters per second, which is what the American Wind Energy Association wants you to rate these devices at, will output 143 watts per unit. The units are designed to be daisy-chained together, and that's one of the keys about our solution. There's some smart MPPT electronics on board that looks at the subsequent and following devices and balances the energy across the DC bus, and will limit its bus to a maximum current of 30 amps on any string. So you can put as many of these things up, you'll get 30 amps out at the end of the day. That's your maximum.
Right.
The device will go up to 500 watts, roughly, I should say, 500 watts, because it's not driven by power output or by voltage. That number is driven by temperature. So on board our electronics, we have sensors that monitor the heat coming off of the board to protect it in cases of high winds. We looked at wind velocities and found that it rarely blows over 30, 40 miles an hour in the urban setting. And over less than 5% of the year do you find winds of that speed. So why build a device that can go up to 60, 70 miles an hour like some of our competitors can do and add that extra expense to the product when you're only going to realize that kind of power generation capability a fraction of the year. Right. So in order to keep our price low, we decided to set our protection circuitry about 500 watts per
17
unit.
meters a second, which is about 35 miles an hour, right?
Right. Over that, we disconnect from the device, we disconnect the load from the generators, and we allow the turbines then to freewheel to cool the device back down, and then they will re-engage.
Oh, that's clever. Good. Okay. Well, here's another piece of technology on this. Go ahead.
Okay. So this is our energy production curve. And in this, you'll see wind speed on the bottom. It'll be in meters per second and miles per hour. And you'll see if you go all the way to the right, past the 10 would be the 11-meter mark, and we are outputting 143 watts. This was measured in a wind tunnel in Mooresville, North Carolina, where they test NASCARs. They run these vehicles in there, and they run the speeds up to 100 miles an hour of wind speed, and measure draft and distortion and things like that. We put our device in there, and I think it has a 6-axis floor, so we could get the loads accurately measured, so that when we do an installation, my engineers can work with the installers if need be and do a proper calculation on the loads that a typical rooftop would be experiencing in a variety of winds.
Okay. Well, now let us go back to the typical user, listener response to something like this. He sees this thing and he's imagining it on his roof, and he's imagining paying whatever dollars for it, possibly at a Home Depot, because it's obviously, to me, it's kind of a slam dunk in terms of home improvement. But be this as it may, imagine buying it wherever you want. But now I'm saying, okay, well, I'm going to get 142 watts out of this thing. So what is that going to do? What is that going to mean to me if I'm consuming, a couple of kilowatts? What's the value of this thing to me in the typical setting? So can you speak to that, please?
Yeah. Our goal is to reduce the need of the utility-provided electricity for a consumer by 10 or 20, hopefully 30%. We're not going to take you off the grid. If you're looking for small wind to be the silver bullet that allows you to live off grid, don't buy turbo mills. Don't buy any small wind, because wind is an inconsistent resource. We look at this device as a means of essentially hooking it up behind the panel on the consumer side of the meter and slow that meter down. Your refrigerator doesn't care where the electrons come from, whether it's, in my case, it would be Southern California Edison or from wind, right? Mm-hmm. But if we can put these things up on rooftops and put them in an area where there is a good amount of wind. I live in California out by the beach, plenty of wind every afternoon and into the evening. And I can generate significant amount of energy over time to slow my meter down. I will realize the savings in a lower electric bill.
Right.
That's all I'm trying to do at this point.
Yes, and you may recall our first conversation in which I asked you that question, and then I realized when I was thinking, who cares about 142 watts? When I looked at the levelized cost of energy of this thing amortized over its life, it's pretty impressive. I don't know the degree to which you want to go into that, but that's, to me, if you're talking about a levelized cost of energy that's really unattractive, and you have this thing on your roof and so forth, that's kind of dumb. But I was pretty impressed by that.
Well, without getting into the specific price point right now, we wanted to build a device that made sense for the consumer. Mm-hmm. And not only worrying about building code issues and aesthetic issues and installation issues, the main driver was price. So what I'd like to say for sake of this conversation today, because we are a new company and we're still working out some of the pricing issues and how we're going to set up our dealer relationships, this device, as it sits here today, is under $1,000. Mm-hmm. So with incentives in California, with incentives that are available from the Fed, you can expect realistic payback periods in the 4 to 5 to 6 year range, depending on your wind resource and your cost of energy, of course. Here in California, I will see that kind of ROI. Mm-hmm. In some of our customers in Indiana, where there's very little wind and coal is the primary source of energy, cheap coal, it pays back in a long time. Yes, it does. No question about it. So in those cases, our customers are the greenwash types of customers, the people who are making socially responsible decisions, buying decisions, and still wanting to do something, that's environmentally friendly.
Yes. By the way, not to split hairs, but I would separate the greenwashers from the environmentalists. So in other words, they're both buying eco-friendly products. Environmentalists are doing it for the right reasons. Greenwashers are doing it for the wrong reasons.
That's right. We work with a lot of corporations. We work with a lot of major brands that are starting to put these things up on their facilities at, for instance, franchise restaurants. They're doing so because, one, we can build a product that can be branded. We can make these things in any color. So, for instance, an IKEA store could be blue and yellow if we were working with them, or a Whole Foods could be green, that kind of thing. That makes a big difference to them. The other piece of it that the corporations are telling us is that, yeah, they can put solar on the roof and nobody cares because it just sits there and they go unnoticed. When you have turbines spinning, it makes people feel good.
That's a good point. And speaking of turbine spinning, let's take a couple of looks.
Sure. So this was our first prototype that we set on the U.S. Embassy in Helsinki, in Finland. And if you see the gentleman on the right, his name is Ambassador Bruce Orrick. Bruce Orrick runs and has started the League of Green Embassies, which is now a consortium of more than just U.S. embassies, but 110 of them worldwide that are focused on energy efficiency. And with Ambassador Orrick, when we showed him our product, and it was a circuitous route to get to him, I won't get into that, his main concern was, does it make fiscal sense? Because he said he didn't care about the product unless it made economic sense, because he can't start a conversation. It's good to do because of global warming. He said it's good to do because you'll save money, and the byproduct of it is it's good for the environment. So when we showed him this device and he kicked the tires really hard, after coming to his own conclusions, he said, hey, how about if I give you the roof of the embassy as your first prototype?
I'll take it.
I'll take it. So we did that in March of 2011 to kick off the League of Green Embassies, and of course that's Vice President Biden on the left, who was there as part of our kickoff. It's a very exciting period of time for us.
I can imagine.
While we were up there in Scandinavia, we decided to meet a few other companies in the area. In the case of Norway, I met with the company Entra Eindom, which is owned by the Norwegian government. They're the largest property holder in Norway. They are trying to get their buildings to net zero. Solar doesn't work in that latitude, so they're looking at small wind technologies. They can't put up big masted devices in their city, and they found our device through some colleagues, and they said, come use our building. So we have two installations actually in Norway. This one is in Oslo, and we have one going up right now in Trondheim. And so far, the tests that we have been conducting there and the data that we have received are all very positive.
That's really cool.
Yep. Next one, Endesa, the national utility of Spain. We're working with them. Spain has a huge push for renewables. Unfortunately, they have no money right now, but they'll get that worked out. And we're doing a project here you see in Malaga, where they installed 3 installations on a beachfront property, which is right across the street from Endesa's offices. I actually think they did this so they can get free paella, but this installation went really well, and they are putting another 5 up in Madrid as we speak. 2 locations, and they're testing them.
That Spain is a little stalled associated with the financial situation, but Spain has done an unbelievable job over the last decade in terms of things like concentrated solar power and so forth. They really led the world. They've
made a real commitment to it.
Yep.
In November 2011, we were able to work with the NFL and Ralph Wilson Stadium, home of the Buffalo Bills, and put up 10 turbo mills on either side of the scoreboard. When asked by the Bills, so what is this going to offset on game day? I said, well, first you got to tell me what the draw is on game day. And it's 6 megawatts for the stadium. Yeah. I said, so the offset that you'll see on game day has too many zeros in front of the 1 after the decimal point to be meaningful.
Yep.
Because I can't compete with a 6 megawatt draw. That's a small city. But what I can tell you is that there are 10 games at home across the course of the year. So the other 355 days I will be producing energy as well. The aggregate will be able to take some of your common area lighting, your office lighting, off-grid. That's the kind of win that we're expecting. Not that we can ever hope with a small-scale renewable energy device to run the stadium or to run the scoreboard even.
Right, I'm with you.
And black tech. So we are working in Brazil. This conversation is focused on the urban space, but there is a great need for off-grid rural installations and providing energy to people who have either inconsistent grid or non-existent grid. So to sell any product that produces power in Brazil, you have to be certified by a company called LACTEC. And we went through the rigors of this installation and approval process starting in November of last year. And late December of 2011, we were finally approved by them to deploy our products in the country. One of the first installations we'll be doing in the next month or so is on a mall in Curitiba. And what we're trying to do is offset their peaks, because from 6 to 9 p.m. in Curitiba, the utility, Celesc, charges the mall $2 a kilowatt hour.
Holy mackerel.
Yeah. The mall is going to store energy to batteries and try and go off-grid for 3 hours a day.
Wow.
We've done the analysis around this with a company called Oxion, who is providing the battery technology in Brazil. And with our technology, using solar mills in this case, we will be able to charge those batteries daily and save them $8 million over the course of this project.
That's fantastic. Boy, that's an incentive. $2 a kilowatt hour.
$2 a kilowatt hour.
Yep.
That's right. One of the projects that we're working on that we're very proud of is sort of an educational outreach program. I've located our assembly facility, manufacturing facility in North Vernon, Indiana, where there are great, great people. And a school, South Ripley Elementary, one of the 6th grade teachers read about us, wanted to do a unit on renewable energy for kids, asked for an engineer to come to the school to talk about it, and we said, we'll do you one better. Why don't you bring the kids to our facility, and we can show them how to build a wind turbine. They came out there. We had a great day with 60 6th graders walking around the facility, and when they came back, they said, we want to put one on our school, and we want to pay for it. So they had a bake sale. I don't know what they did, car wash, but they paid for this device, and it powers a light in their hallway. So the wind is turning. There's lights now in their hallway, off-grid.
Oh, that's fantastic.
Yeah.
Good job.
And here's something that we're doing right now with our customer in the military. We're working with the National Guard. The National Guard is obviously driven by the same mandates across DOD, and they're trying to get their facilities as energy efficient as possible. So in Seagirt, New Jersey, we were able to put up a single unit for analysis. The military wanted to make sure that this wasn't snake oil, that it would perform as we advertised. They put it up there and monitored it, and in fact, we performed exactly as we said we would, generating the energy that we said, and they have subsequently gone ahead and ordered a whole bunch more for the barracks in Seagirt, New Jersey. This led to other installations in Indiana and now in Georgia, the National Guard in Atlanta, Rhode Island, Arizona, as it's rolling out across the military.
Mm-hmm. That's good.
Okay.
So we don't have to spend any real time on this thing, except let me just editorialize and say that I've seen the sales pipeline, and it's as long as my arm. What you've done in a very short period of time, I think, is a testimony both to your how hard you folks work, but also the demand for a low-cost product like this.
And that's really what resonates with folks, the cost of the device. People get a little gun-shy when you start talking 5 figures for wind.
Yep.
They do.
Yep.
And when we're talking 4 figures or less, easily installed, of all the installations I just showed you, not one has a roof penetration. Mm-hmm. These are all ballasted. Mm-hmm. And the device can handle that. That's what it's designed for. The original thought was the guy walking down the aisle at Home Depot would be able to see wind energy and get it home. That was an undertaking. Put it in a box that fit in a car, and we've achieved that.
Yep, exactly right. And here's where you've achieved it.
Yeah, so we are building wind energy devices, turbo mills and solar mills in North Vernon, Indiana. If anybody out there knows Indiana, it's about equidistant between Indianapolis and in the South Louisville, 50 miles away, right in the middle. This was a factory. It's 45,000 square feet. That was the largest employer in the city, I believe. It was called Regal Rugs. We took over the factory. They moved out about 10 years ago, cleaned it up, and have set up our assembly lines. We brought our own painting in-house. We build our own generators. In the lower left corner, you see a gentleman there assembling generators, which we have designed uniquely for small wind. We didn't buy a generator off the shelf from China. We decided to take a look at the requirements that were needed to operate in a low wind environment, and Stephen Brewer built a genius piece of technology that takes advantage of those low wind speeds.
Yeah, that's fantastic.
Yeah.
These are a couple of the competitive advantages that we haven't completely touched on. If you want to go at them.
Well, first and foremost, I think, is price. That has to be the number one driver.
Precisely.
Scalability, of course, is important. What we like to say to our customers is try one out. Put one up on your roof, put a couple on your roof, and see if it works. See if you're generating the kind of power that you think would be meaningful to you for the price. And if you want to add more later, you can simply plug them in. You don't have to redesign the system. You just keep adding them. You don't need to lay a foundation. You don't need a big pole and guy wires and masts and all the rest of the things that make installing small wind in the city setting either unachievable or cumbersome. I think that when you look at our competitors, you look at masted devices by and large, and I agree with that. This is known fact. This is nothing that I'm going to go against. The higher you can put a windmill, the better. But if you can't put it up because building code won't permit it, then it's a non-starter. Then you need to find something that can work in the environment that exists, not I'm living in Southern California and I wish I was on a farm out in the country so I could put up a big, tall device. Right. That's not an option. So if you don't have that as an option, what's your next best choice? Rooftop mounted. If it's rooftop mounted, it needs to be inexpensive and needs to be flexible.
That's exactly right. Let's conclude with a statement, and I don't know exactly what you want to say at this point, but where are you with respect to corporate development, let's just say, and investors and moving this forward? What needs to happen?
Oh, boy, that's a loaded question, Greg. We are a small company. We've been shipping products since March. We've built over 500 units. We've sold out of all of them. Everyone is spoken for. In fact, I now have a backlog. So as a small company and as a growing, emerging manufacturing company, unlike a software business where you got guys in a cube and you can ship ones and zeros out, no problem, we are in a capital raise. We're looking to find some growth capital, expansion capital, from which we can build our sales and marketing channels, and we can start delivering on the orders that we have already booked.
Okay.
Plain and simple.
Well, sounds good. Thanks very much. And anybody, by the way, who's interested in playing a role in that and becoming a kind of partner in the company, I suppose, although I don't know the details of what Dan's talking about here, but anybody who's interested in exploring that with Dan, just hit the contact button on the website, and I will connect you with Dan.
Oh, excellent.
Dan, thanks very much. Are there any things that you'd like to say in closing?
It's an exciting space, and I'm real proud of the team that we've built. We have great guys in manufacturing who have been around from Tier 1 automotive manufacturing forever, so we know how to execute on this product. It's an exciting product. It's an exciting time to be in this sector, and I want to thank you, Craig, for allowing me the opportunity to present this to your audience.
Well, I was delighted to give you that opportunity. I really believe in this. So, again, thanks for being here, and we'll talk again soon.
Thank you very much.
Okay.
Bye-bye.